Let's get started. So welcome everyone. I'm very thankful for everyone for taking the time and attending this webinar on accelerated EV product development with simulation technology. It is my pleasure to introduce our expert speakers for the panel discussion today. So we have Dr. Dev Mukherjee. He's an expert in the Indian automotive industry with a career spanning over 30 years in different leadership roles. So currently, Dr. Mukherjee is serving as the managing director at Omega CK Mobility. That's an EV company manufacturing EVs across vehicle segments. Next, we have Mr. Rupesh Khopade. Mr. Rupesh is presently working as industry process consultant with Dassault Systems India, and he's actively working with multiple electric vehicle OEMs, startups, and suppliers to help them adopt and set the design, manufacturing, and marketing processes. And to moderate this session, we are pleased to have Mr. Kiran Bhokare, solution engineer at YS. So Mr. Kiran has more than 11 years of experience in engineering consulting in the area of design, digital manufacturing, and validation. So before I hand over the session to Kiran, I would request our audience to answer one quick question and then we can get started. You can indicate your response. We'll wait for a couple of minutes for all of you to indicate your response, and then Kiran can start with the session. We'll wait for a couple of minutes for all of. Okay. All right. Kiran, I'll now hand it over to you to start with the session, please.
Yeah, thanks, Priyakshi. So, good afternoon, all of you. Today we are going to go through a topic which is accelerated EV product development with using the simulation technology. So basically, we will be talking on how we can improvise the product development process using some simulation tools. I will directly take you to the agenda. So we will be touching on the points like what is the industry overview of EV for an EV vehicle, then design and modeling and the simulation of electric vehicles. What are the challenges? What are the processes involved in this? Then we will go for the manufacturing of EV, which is another important aspect. Then promoting and selling of EV. Further to that, we will go for a case study for EV and conclusion and key takeaways. And after that, we can go for our question answer session. So to go through the EV industry overview. Yeah. So maybe Rupesh, you can just answer. You can just answer for this. If we talk about the segments of electric vehicles, and what is the current trend going on for the electric vehicles, and in a geographic point of view, where we can where the electric vehicles has been percolated. So we need to understand from you, as you are an industry expert. Maybe you can put your thoughts on this. Over to you, Rupesh, for this.
Thanks, Kiran. Thanks a lot. And first of all, good afternoon, everyone, and welcome to this webinar. So if we talk about India as a EV market, slowly more and more states are adopting this EV policy. They are putting their norms in place. Initially, there were only a few handful of states which had announced EV policy. Now we can see that number growing, and if you can see here, almost around 11 states across India have announced their EV policy. If we talk about the vehicle or portfolio, or the category of vehicles which had seen adoption of electrification, so there are leading segments like e-scooter, e-rickshaw, and in public transportation, the buses. And we have seen many global players also coming to the Indian market in this particular segment, which is followed by the three other categories like e-motorcycle, then e-auto, and of course now there are passenger cars also available in the market. So that is going to lead this electrification going forward. And there are other segments like heavy trucks and light commercial vehicle and good carriages, which are still picking up this electrification wave as far as Indian market is concerned. Also, there is one more important category, which has emerged in due course of time, and that's basically the charging infrastructure companies. So there are many players coming up with for their solutions for charging infrastructure, providing this facility across multiple cities, not only metros and tier one, but now they are kind of spreading this network in tier two cities as well. So this is basically a kind of quick overview about how electrification in India is up to this date.
Yeah, thanks, Rupesh, for the inputs and your thoughts. Taking further this topic, if we go for the EV industry, so presently we see that the traditional IC engine suppliers, they are moving from IC engine manufacturing to a EV industry. So I like to understand from Dev Mukherjee sir, what are the drivers and challenges which we will be facing when this transition is happening in the industry. So over you to Dev sir. Yeah.
Thank you, Kiran. And first of all, good afternoon to everybody. And thank you, Priyakshi, for inviting me and having me on this panel. And thanks, Rupesh, for the introduction to this discussion. Yeah, I think as you have put in rightly that slowly we are seeing this transition happening globally. India is also going to be a very, very much a part of it. I don't see that India remaining aloof from this whole transition. This is going to be a global phenomena, and electrification is probably the most significant impact on the auto industry that we will see, in the whole history of automotive industry. So to answer your question of the drivers and challenges, I think this is a very relevant topic being debated all over. To my mind, the main drivers today are a couple. One is the government policies, because especially the present government has been very sort of persistent with its policies on EV and on the environment side. First we had the BS6, and then consistently we are seeing a sustained push towards electric vehicles. That is on the central government side. And also, since it becomes a state subject, so all the state governments are coming out with their own respective policies one by one, giving various incentives or the permit fee exemptions, road tax exemptions, etc. So that's probably the biggest driver, as I see, to this whole movement from IC engine to electrification. Then I see another driver is the the technology readiness. Today we have a product ready. It's not a product which are under incubation or under lab. So now it is in the market. We have a stable product. We have a roadworthy product, a safe product, which can comfortably be used by customers without having a worry. Of course, the charging, etc., is an anxiety that we'll talk later. But the technology readiness is there in terms of battery, in terms of powertrain, and the vehicle as a system. the whole ecosystem is there today. And the third driver, of course, the biggest is the economic driver, because end of the day, everything boils down to the price. So in case of India, we are seeing the first segment which is adapting to the EV is the commercial segment, whether it is three-wheeler or even two-wheelers being used for commercial last mile, etc. So the reason is simple, the running cost is probably, 50, 60 paisa instead of 5 rupees or 6 rupees for a diesel run vehicle. So it's a tremendous economic benefit to the user, especially in the commercial. And slowly, as the awareness comes, the whole ecosystem develops, then the the personal vehicles also will adapt. Now, coming to the challenges, I divide the challenges into two areas mainly. One is the supply side challenges, and then we have the demand side challenges. As a maker, as an OEM, I can reflect on both. You see, on the supply side, we see the major challenges are, the battery manufacturing, and obviously the cost, because you see the cost of battery today, is something like 40% or 45% of the whole vehicle. And the cells have to be imported. We don't make the cells here. So those are the challenges, mainly on the the whole supply line. Then the whole supply chain has to be set up accordingly, because this is a complete different manufacturing system. And I think going forward we'll talk more about it, the role that technology plays in it, the design and the simulation technologies play in it. But broadly, battery and the power electronics remain the major challenge on the supply side. On the demand side, there are mainly two challenges that we see today. And these are, one is the charging station, which Rupesh touched base on. Of course, there is a lack of charging station that is getting created because of, the various infrastructure costs and timing, etc. To set up that infrastructure on ground takes a lot of time in India. And also it's very expensive. So that's something that I think the government and government agencies, public sectors, etc., will have to take a lead in that. So that's one challenge. And second is the financing aspect. As you know, on the commercial side, especially, almost 70-75% of vehicles get financed in India on the commercial segment. That is where I think we find a challenge that, either whether it is banks or financial institutions, lending institutions, and BFCs, they are not so keen to fund. There are reasons for it, because it's a new segment, and they have in their mind, they feel that it's a low end, low quality vehicle. The picture in the mind is that vehicles running up and down in the the cities and metros, etc. So because of that, they don't want to lend, thinking the recovery may not happen. So these are broadly two challenges that we have to encounter. And I think going forward, as the industry evolves and develops, these will have to be handled by the OEMs. That's my view.
Okay. Yeah, thanks, Dev sir. It was a very good insight related to the drivers and challenges of EV industry. Rupesh, you may like to add some points related to the battery challenges.
Yeah, so as Dev sir mentioned, for one important aspect of electric vehicle is battery, for sure. Almost 40% of the cost is incurred on the battery. Also, localization of battery pack is an important challenge, specifically for our tropical, subtropical conditions, wherein high temperature, high environment temperature will lead to battery heating, which in turn will lead to deterioration of the performance of the battery, right? So those are kind of very specific challenges for Indian environmental condition, for which we will have to do a lot of validation, simulation, in order to cope up with better design criterias, better manufacturing solutions to put together battery pack and effectively ensure the performance of the battery pack over the life cycle of the vehicle.
Thanks, Rupesh. So in addition to the battery, if we talk about the systems and subsystems which we need to handle in a electric vehicle, if maybe Rupesh, you can just give a glance of that, maybe.
Yeah, sure. Thanks. So typically, these aspects, the key drivers can be broken down into two segments, I would say. The first one is specifically on the OEM side, and the other set of drivers are more on the ecosystem or more on the supplier side. So for example, if we talk about the electric drive, the chassis, the vehicle architecture and body, right, and to some extent the power electronics which is involved, uh, definitely OEM has to deal with these drivers. They have to come up with the infrastructure in order to design, develop, and manufacture these systems and subsystems. And on the supplier side, definitely along with the traditional supply chain, definitely a lot of components which are coming from our legacy IC engine vehicles will fit in the electric vehicles as well. But there are certain areas, say for example, battery, as we discussed, is an important topic, and the ecosystem and the supply chain has to develop, and that's the real challenge as far as India is concerned. Another important topic here is the systems which are driving for current, which are driving energy from your battery pack, are again load on the vehicle, and which in turn will impact the performance parameters like range, overall range of the electric vehicle. And that's where there is a lot of consideration specifically on these systems, like your lighting system. A lot of innovation is happening in the lighting systems in order to be more energy efficient. Similarly, the HVAC systems, a lot of studies are going on in order to adopt these HVAC system to be efficient enough in terms of performance, also to be very efficient on the energy consumption. So these all these dynamics, all these evolution of the ecosystem is happening, and it's a great time, I would say, wherein you're looking at a lot of things happening in this particular space.
Okay, thanks, Rupesh, for the input. Dev sir, maybe you can also add some inputs related to the key drivers.
Yeah, I think Rupesh covered it very nicely. You see, as I see that this is a completely a different, design approach that we will have to take going forward. The auto OEMs I'm talking about, because the vehicle has to be designed around the battery. If you see the slide you are showing, the battery is mounted on the floor, and that's the skateboard kind of design that the modern car makers are talking about. So it can be made in a modular way, a sort of platform agnostic designs, etc. So that's one challenge that we, or rather one consideration that we must have. The whole vehicle has to be designed around the battery. And now there are various new technologies coming, like solar panels getting embedded into the chassis or the body parts. Even there is a Netherlands-based company which is making the hood, the front bonnet of the car out of solar panels and getting embedded into it. So the whole car becomes a battery. So those are the new innovations that we will see probably going forward. But yes, I think the electric powertrain is the key, driver to the whole engineering or the vehicle architecture, as we call it. And it has to be designed along with the powertrain maker. We can't just be using some off-the-shelf, motor or gearbox and just put it on four wheels. I think that's a wrong approach. Maybe on the smaller formats of two-wheeler and three-wheeler, it's probably possible, but on passenger cars or LCVs, etc., the whole design approach has to be very, very comprehensive. The OEMs have to work together with the battery and the powertrain makers, and then it has to be designed as a complete system, not just an add-on. Take out the IC engine and put the battery in or powertrain. I think that approach will not work.
Yeah, very right, sir. Very right. Thanks for the inputs. So, if we go for the design, modeling, and innovation concept of for a EV vehicle, again, if we specifically talk on the battery management system, so maybe Rupesh, you can add in this what all things we need to consider while doing a battery management system.
Okay, so before directly going to the BMS part of it, few of the parameters which I already discussed, specific to the Indian, environmental conditions. But before we reach to that level, a lot of study has to be done specifically on the overall battery capacity, deriving those component level specification right from the vehicle level requirements, right? And a lot of study, has to be done specifically by the startups, OEMs, new OEMs entering into this particular market, because overall vehicle packaging and vehicle sizing, component sizing, and how much the battery, the charge storage capacity of the battery should be there, and how much, what should be the discharge, for cycle that you need to test. So there are certain norms which are already put in place by certain agencies. There are driving cycles available against which you can estimate the battery performance and the requirements related to that. And three important aspects when it comes to the overall battery pack are important. One, definitely the overall battery life. You can divide it into two. Say, for example, the calendric aging. Even if you don't charge or discharge your battery cell, over a period of time, they are going to degrade in terms of performance, right? So that's what we call it as calendric aging. Then we have cyclic aging, right? With every charging discharging cycle, the battery is losing its life, right? So that is an important aspect. Then the thermal management is another important aspect, wherein for how much how much is the heat generated, specifically taking into consideration the external environment condition and the load cycle that you are running on that particular vehicle, right? And then having an efficient battery cooling system in place, so that you will be able to ensure the overall life of the battery over the period of vehicle life cycle. Aspects and which needs to be studied and put in place before going into the development of the vehicle.
Okay. Thanks, Rupesh. Dev sir, will you like to add some additional points in this, the battery management system?
Yeah, I think, from my side, what the challenges or the issues that we face, when we work on a new platform, is that, one is the availability of the battery pack. I'm talking in the context of India. The availability of the suitable battery pack that we have to use in our vehicles. It has to be customized. It has to be also, we have to see the optimization of the energy consumption, because it's an energy source which is driving the whole vehicle, and it is communicating continuously with the drive line. The motor is talking to the battery continuously, and the BMS is deciding how much energy is required, or what sort of environment it has to operate. So I think that the engineering part of it, the chemistry selection, the cell selection, the capacity decision, and the whole vehicle architecture is determined by that. The whole, then the mechanicals come in, the weight of the battery, the placement of the battery, whether it will be single pack, multiple pack, etc. How do you place it? How does it affect the dynamics of the vehicle movement, toppling, whole uh, vehicle performance. See, so these are the aspects which need to be considered in detail during the vehicle design, and that is where the design simulation packages to play. Nowadays, you simulate it, you can make a complete simulation without going in for a prototype or a mock-up or something. So that is the where I think the real challenge lies, customizing the battery pack according to your whole vehicle system.
Okay, thanks, sir. So further moving to the design, modeling, and simulation of electric vehicle, maybe Rupesh, you can just brief about what are the, I will say, stages while doing all these things, and what is the complete process which is involved in a design phase, I will say.
Okay, based on our interaction with various OEMs, startups, and the member of the ecosystem, we could understand the challenges specifically upcoming OEM or a startup is facing are primarily on the three different folds. One is the first one is how can I design my overall vehicle? How can I manufacture it? Because we have seen this is first threshold that many startups are coming up with a viable product, but then getting into the next stage of actually manufacturing it, and then the third stage wherein they start the sales and distribution and the revenue generation is a practically possible for that particular startup. So those are the three important I would say the categories of the challenges what an EV startup is facing.
Okay. And taking further this topic, if we go for the uh, design process, so what all the process challenges EV startup can face?
So there are many challenges when you start to start design a new vehicle from scratch, and before it becomes a commercially viable option. Okay, so and it's on the again different. I would say it has got different facets. So for example, what we are looking at here is more related to the mechanical design. So similar process you will have to consider for the electric powertrain as well. So if you talk only about the mechanical design of the vehicle, definitely it all starts with your architecture, right? The to study and validate overall vehicle architecture parameters, and then putting into place your styling team and class A surface refinement, and then coming up with your first physical prototype, which is further refined and studied for various simulations like durability, then fluid studies specifically related to the overall performance of your vehicle. And once you pass over to that particular stage, then gets into the detailed design of your structure, then the manufacturability study of your structure, and then the detailed engineering, which is in turn followed by the overall component development, working with the suppliers, sourcing different components, and then for finally putting into the place the manufacturing, coming up with the final model, the manufacturing process for your vehicle. And the downstream very important step related to the sales and distribution, setting up the sales and distribution channel is definitely a big challenge that we have seen for these startups who are coming up with their new vehicle ideas.
Okay. Dev sir, as a OEM, EV OEM, do you face the same process challenges what we have highlighted here, or are you having some additional inputs to be given in this?
Yeah, I think more or less these have been summarized well. I would only like to touch upon one or two key aspects of this whole process. You see, first of all, automobile vehicle development is a very sort of robust process which is followed globally by OEMs traditionally. You have the styling, then architecture, then going on to the surface design, then the engineering kicks in, the whole part design, etc happens in a, let's say, a time frame of something like 1.5 to 2 years, etc, before you come out to the serial production. Now, a couple of things are happening here. You see, EV, as I see, is a big disruptive technology. One, because it's a completely different, obviously the driveline, the fuel, etc., is completely different. Secondly, the whole EV business itself is becoming more and more like a huge technology business, and that is how the successful companies are seeing this, and we are seeing more and more competition coming from these startups or non-traditional automotive companies. The reason is that car making or vehicle making is moving more very, very quickly from the traditional model of assembly of various parts or mechanical assembly. It is going more and more into the high technology area, aided by simulation and other tools. So the modern cars, for example, the 50% of the costs are all electronics of it. Okay, the electronics costs are roughly about 50%. There is a Deloitte study which says the market is something like $500 billion of electronics coming up. So that's the kind of business we are talking about. So what I'm saying is that along with these traditional processes, the OEMs have to look into the infusion of these technologies. I'll give you one example. In our case, we designed and developed the three-wheeler entirely in-house. We started about 3 years ago, and we have no import content at all, except obviously the cells which get imported, and the battery pack is manufactured in India. Other than that, everything, we did the designing, the prototyping, and durability testing, everything in-house. Now, coming to the timeline required, it took us about 3 years, but today the modern companies should be able to do it, less than a year, and that's what we are going to do in our new, the next model, and we will probably come out with our new product like a two-wheeler in less than 6 months. So these are the learnings that we have, and also, in our case, we see ourselves as a technology solution provider to our customers, not just a manufacturer or a producer of vehicles, but we see in our case like a complete mobility solution provider, aided by our technology, which is again developed in-house. The algorithm decides what vehicle is required for a cargo service provider. It picks up the vehicle, deploys it, then tracks it, decides the optimized route, etc. So that's a big part of the whole product development cycle. I think that is where the change is coming, primarily brought by the EV. But again, this will probably become very much standard for normal IC engine vehicles also.
Okay. It was a very good insight given by you, sir. This will help the EV startups also. So going further, Rupesh, based on the design, modeling, and simulation of EV, solution point of view, if we talk, So what all solutions we are having to cater all the requirements in a EV industry? If you can brief about that.
Sure. So Dev sir already mentioned, briefly about this particular point. So how do we compress the overall vehicle development time, right? Initially, say if it is taking of effort in order to come up with always of effort in terms of initiative in terms of how do I reduce that overall vehicle development cycle time. Important aspect which takes a lot of time and a lot of iterations happening, and you cannot avoid this in that particular process is the industrial design, right? The product that you want to bring it to the market has to be emotionally appealing into the today's competition, because that kind of decides the success in the market. So how do I do multiple options, or how do I evaluate multiple options for my industrial design for the vehicle? If it is the legacy, definitely it will take a good amount of time, because first you will have your clay model in place, then you will digitize it, and then put the physical prototype. You need to procure component or develop that component specifically for validation purpose, which is a sequential process. And in the meantime, if you identify some challenge into the design, you will have to that process, right? So this inception process in the physical world, we can leverage enhancements. So we are talking about 3D experience platform, which be electric bike or passenger car, or even to the scale of the commercial vehicle city bus. You can create that experience in the digital environment. You can it against the human, right? Human in early in the design, very good judgment about the proportion.
Hello.
Yeah, sorry.
Sorry, Mr. Rupesh, can you please turn off your camera? We are having some bandwidth issue at your end, so your voice
Okay,
is breaking. Maybe
sure,
that is at the bandwidth. Yeah.
sure. I can do that. Let me know if it is helping now.
Sure. Please go ahead. Yeah.
Yeah,
Yeah.
thanks, Priyanshi. Okay, so yeah, I was talking about the immersive visualization capabilities, right? In order to validate your vehicle uh, in the digital environment itself, can bring in a lot of value in terms of overall time compression for vehicle development, right? So these are the few solutions which can be used pretty early in the design cycle, which can help in long term.
Okay. Okay. And further, if we go for the engineering of a EV, so what all solutions we can use to do a proper design and validation of a product, I will say. So if you can give some insight on this.
Sure. So the first aspect of this is, which is related to the mechanical and shape design and validation, the process we already talked about, right from the overall vehicle architecture parameters to the manufacturability analysis of various components and subsystems and systems putting it together. Coming to the next topic, as we have discussed about that simulation is an important process for validating the vehicle performance on road, specifically for the electric vehicles, because electrification brings in complexity of a different scale, right? Earlier, we used to talk only about the mechanical systems, but now things are becoming more and more complex with electrification. As Dev sir mentioned that more than 50% of components in your vehicle would be related to the electronics. It's becoming a multidisciplinary engineering challenge, which involves mechanical, electronics, and electrical. On top of that, there would be challenges related to for ensuring the safety of the overall vehicle, because you will have very high energy density for vehicles, and your components would be running at, say for example, your motor would be running at very high RPM, right? So in order to ensure the noise and vibration levels, in order to ensure the durability, in order to ensure the safety of the overall vehicle, uh, this simulation process has to be leveraged to a greater extent, wherein you have to do not only one discipline of simulation, but the multiple discipline of simulations. So that's one important solution that we can deliver on 3D Experience platform. And of course, the collaborative way of designing can reduce overall vehicle development time. So for example, I was talking about HVAC development. So there has to be a collaborative effort between the supplier team in order to come up with efficient HVAC system for not only for passenger comfort, but also to ensure the efficient cooling of your battery and other electric drive line components. So these are the three different aspects, like mechanical design, your simulation and validation, and collaborative workflows would kind of add a lot of value for electric vehicle development.
Okay. Thanks, Rupesh, for the inputs. And further, if we go for a smart system design and validation, solution point of view, maybe you can give some insight on this also.
Yeah, so I touched upon for the mechanical side of it and then validation, but of course, just like you have upstream industrial design process wherein you need to ensure that everything is correct by validating multiple options and selecting the best option out of whatever available. But apart from that, in order to manage the complexity of multidisciplinary engineering, there is a concept which has been widely adopted into the industry, is model-based systems engineering. Okay, so in model-based systems engineering, you break down your requirements to the functional level. Okay, what different functions my vehicle need to perform, and then you can break it to the logical architecture, and then finally you basically detail out that logical architecture to come up with the physical system. How it helps is you can bring it back those components with various stages of verification, validation, and qualification, right? So this entire, what we call it as V curve, really helps the organizations to manage the complexity and to have the predictability in terms of performance of the vehicle. So this 3D experience platform, what we are talking about, has got that backbone of model-based systems engineering, which can be leveraged to a greater extent for handling such complex systems.
Okay. Dev, sir, any inputs from your side related to this design, modeling, and simulation of EV?
Yeah, I think Rupesh has covered it very nicely across the whole comprehensive design requirement for a electric vehicle, the mechanicals, the electricals, the powertrain, and the whole, the entire EV platform. So I would only say that, there are, these are very powerful tools, and we have to, OEMs have to utilize these tools and technologies today. See, the whole success depends upon couple of things. One is that the timeline. Today everybody is in a hurry, and we have to, whatever stage of business you are in the early stage, maturity stage, or later stage or declining, you have to shorten the the product life cycle basically, and then come up with something, either a new product, new technology, new platform. And second is, now going forward, customer wants customized products. It's the age of customization. Tomorrow maybe we'll have to build cars customized to customers' requirement, who will order probably online to us. So that's probably is coming soon. So these are the tools. Without that, it's not possible, to my mind, to really design a high technology product like car, and especially EV, because as Rupesh said, the safety is a very important part. These are all high voltage systems. And also, the NVH requirement, for example, are totally different from the IC engine vehicle. So, the whole simulation has to be done customized to an EV. Also, the heat generation, the entire electrical system, the cabling, wiring harness, connectors, etc., they have to be designed to take the load of these high voltage and high energy consuming components. So I think that is where these technologies help. And you have built enormous amount of capabilities for simulation, and you have the libraries where we can pull down what sort of systems can be used across the platforms, and thereby cut short the lead times for development. If you go just sequentially, then probably it's going to take even more time than a traditional IC engine, because it's a completely new domain. But using these tools and products, high-end products like this, I think you should be able to do it in a very short time.
Okay. Thanks, sir, for the inputs. Further to this design, modeling, and validation process, we can just focus on the maybe the manufacturing aspect of the EV. Rupesh, you can take us through the what are the manufacturing aspects, and maybe what solution we provide related to manufacturing.
Sure, Kiran. So this is an very important topic, I would say, because while interacting with specifically with the EV startups, we see there are a lot of startups who have come to the stage of physical prototype of the vehicle. Okay, but the real challenge where they face is, to put in place the real infrastructure to manufacture that vehicle and bring it to the market. How we can help is, say if it is a greenfield project, for example, wherein you're coming up with a completely new manufacturing facility, we can provide the solutions which will, help you to do a lot of simulations related to manufacturing processes. How am I going to assemble my vehicle on the assembly line, right? So those kind of simulations will help you. How am I going to arrange different stations on my manufacturing line? And then there would be a lot of what if scenarios. What if I do this? What would be its impact on my overall throughput? And also to identify the bottlenecks in my manufacturing line before I start, putting that manufacturing line in place. So those are a lot of studies which can be for which we can leverage what we call it as 3D experience screen of your manufacturing line. Okay, so you have the complete model along with its behavior of your manufacturing line in the digital space, and you can validate it in the digital space and address those challenges before they get into the physical world. So it helps a lot. Also, when your manufacturing setup is in running stage, there are a lot of processes like the scheduling, the operations management, S&OP. So all those are categorized as for manufacturing operations management. So the digital platform will help a lot in order to control the ongoing manufacturing process and to ensure the productivity of your system.
Thanks, Rupesh. Dev sir, being a EV OEM, are you facing any problems or issues related to manufacturing? And if any problems you are facing, how you are trying to solve that or cater that?
Yeah, I think you see, any new venture has to go through a learning curve. Only thing is, with your experience and knowledge and infusion of technology, you can reduce that learning curve. But especially in a country like India, where there are several challenges which we have to encounter quite frequently. So the point here is that how to assess these issues or problems that you may encounter, and then build your system fail safe or close to fail safe system, so that you don't end up in problem. That is the key, and that is where technology helps you. You see, broadly what Rupesh showed, we can use it first of all to decide the whole manufacturing strategy. What is going to, in that, make versus buy comes the first important decision that you got to make, that what all processes you are going to have in-house and what all you will outsource from your suppliers. Then accordingly you will set up your supplier network accordingly. Whether you want a particular buy a part, or you want to buy a subsystem or a complete system, whatever. So that's the part of your important manufacturing strategy. Then comes the whole manufacturing process, or what we call process engineering or industrial engineering, the line layouts, the cycle time, throughput times, number of people required, etc., layouts, etc. So that is where these simulation tools help enormously, because you can simulate in various ways depending on what you need, what is, and also you got to keep in mind what is going to be your future requirement, because you should not end up with excess capacity. At the same time, you should not end up with less, you should not run out of capacity. So you got to plan for, let's say, 1 year, 2 year, 3 year, whatever is your assessment of the market. So this is where we need to use the technology to decide what is going to be my manufacturing sort of horizon next 3 years down the line. As far as challenges are concerned, the supply chain consisting mainly of battery, powertrain, etc., because the suppliers are few and we have to sort of work together with them. So those are the initial challenges that we have to undergo. But once the supply chain is in place, then it pretty much runs smooth. Then it's a matter of just churning out the numbers and ensuring the product quality, etc., and giving the after sale service. Even on the marketing and after sale side, there is a huge input which where these kind of simulation tools help, because we capture enormous amount of data today from our customers, from the users, from the vehicles on the fleet, because today the car is like a huge computer on 4 wheels. It is processing a huge amount of data. So that data needs to be analyzed and then utilized based on what you are going to do, whether it is predictive maintenance or the life of the particular component, motor, electricals, whatever. So that is where these simulation tools and technologies come in handy.
Yeah, thanks sir, for the input. Further to this, the another challenge what we are facing presently is promoting and selling our product or the EV vehicles in the market. So maybe Dev sir, you can try to focus on this. Maybe you can give your inputs on this.
Yeah, going forward to where I left last, so what I'm saying is that this is a new product. So obviously there are questions in the mind of the buyer. One is obviously the cost and the range anxiety, that if what will happen if I run out of battery, and or is the vehicle safe, or and end of the day, everything boils down to the cost. So promotion side, I see the challenges are these, whether it's on the battery charging side, and again the economic part of it, the financing and the whole, using it uninterruptedly, because this, for example, the commercial vehicles are all, like the business earners for the user. If it is a three-wheeler, for example, so the vehicle should be up, 18 hours, 20 hours, whatever, in a day. He should be able to run it in a very, fail-safe manner. So marketing and creating this whole new space is the challenge. We have to sell this concept that this is our vehicle is not something that will break down on the road, or it will have a life of 6 months or 1 year, for example, the low-end Chinese imports are. So we are giving a durable, long-lasting vehicle in the market. So that is, the biggest challenge. And then giving the solution, that's what I feel is going to be a huge market, and that is where the industry will go, because car or a vehicle is not just a hardware, a piece of hardware. It is, again, it has to be a complete solution. For example, in case of mobility, like we are doing, we are running on a operational mode. We run our own mobility as well, and we finance it. We have the operators, we have the people who do the maintenance, etc. And that's where we are a complete one-stop solution provider to our customers, like e-commerce guys, etc. So I think once you package it in a way that it's a complete service, not just a piece of hardware which you just sell and forget. So that is where the market lies. And I think more and more the market and the revenue streams will come from that space.
Okay. Thanks, sir. Rupesh, marketing and sales point of view, or promoting your vehicle point of view, what solutions 3D Experience platform can give us?
Sure, Kiran. I think I will have to be very brief about this since need to be mindful about the time.
Yeah.
But I will try to touch upon, say, so sir mentioned, Dev sir mentioned about, different trends into the market, So what we understand is you need to listen to the market, right? So we do have tools which can help you to do social listening. Okay, but people are talking about electrical vehicles in general. What are their queries? What are their questions, concerns? If you really want to understand, you can do a social listening dashboard, which will help you to understand the buying pattern, the priorities of the customer, and which you can imbibe those aspects in your vehicle right in the design stage itself, right? So that is one of the aspect. Another aspect, is most of the time, the buying decision is taken even before you enter into the showroom, right? And that's the power of the digital media. The perception is already created, not only for the bike or the for electric vehicle, for that matter, any product in the market today creates an impression on you through a social media, right? So we can deliver the powerful tools using 3D Experience platform, which can help you to create those digital assets to engage with your prospective buyer and make an impression on them about your vehicle, that the vehicle that you're going to bring to the market. And that can help a lot specifically for the emerging OEMs.
Thanks, Rupesh. Rupesh, if you want, we can just go through the case study of Dassault Systems, what case study we are having presently.
So there are many case studies specifically for electric vehicles. So specifically, the solution that we have developed has been tested and used by multiple leading electric vehicle OEMs, including Tesla. So this is one case study that we discuss a lot. It's a Canoe, which is a California-based electric vehicle startup, and they are coming up with the shared mobility concept, wherein they are using the 3D Experience platform available on the cloud. And the value that they're getting from the solution on the cloud is the scalability. Initially, they started with very small investment, very small team, which now have grown into hundreds of users, and the complexity has gone into different domains, right? So that's the power of cloud. If you want to get a world-class infrastructure, either you have to do good amount of investment upfront for on-premise setup, or you can go and get those solutions directly available on the cloud, and you can scale up. So that's one important aspect. We would like to highlight specifically about this case study. Of course, there are many others. Maybe we can discuss at length at a different point of time.
Okay, okay. Thanks, Rupesh. So overall, whatever discussion we had with our experts, so these are the conclusion and key takeaways which we need to focus on. So planning is a crucial in the transition phase when we make a transition from IC engine to EV vehicles. Then, as Dev sir mentioned, the government policies and support. It is also an important aspect in this. If we go further, we need to focus on specific domains and verticals to be targeted for business requirements. And as we talked about the battery management system and the charging infrastructure, that is also a crucial area to be handled in the EV. Key takeaways are Dassault Systems is having a mobility accelerator solution which can cater maximum EV related issues or challenges. So maybe we can talk about this in the later phases. And as Rupesh mentioned, that cloud solution is always available for easy access on 3D Experience platform. Uh, this is the end of this session. If you are having any questions, you can just ask. This is open for a question now. So our experts can give you the answer for your questions.
Thank you. Thank you, Kiran, and thank you to Mr. Rupesh and also to Mr. Dev Mukherjee for such an insightful session. I think I will have to go through the content once more to actually absorb and all the insights and all the knowledge I've gathered through this session. So thank you so much for that. So we have a lot of questions actually, and we are short on time. So we will extend the webinar time to 10 more minutes, and we'll move on to the questions. I'm launching a quick 2 questions poll before we move on to the Q&A. So I would request all the participants to please indicate their answers. Thank you. And there is one more small question. I'm going to wait for another 5 seconds. Thank you. I'm ending the poll now. Thank you so much. So we received quite a few questions at the time of registrations itself. So first, we will move to those questions. First question is from Mr. Rahul Bhargava from IEEE. And his question is, how to stress test virtually to identify the points of failure for particularly batteries, who has CAD models and base physics parameters. I will type in the question in the chat window so that our panelists can have a look. So this is the question from Mr. Rahul Bhargava. I would say any of the 3 panelists, 3 experts can feel free to take the question.
Okay, so this is Rupesh. I'll just give a try. What I understand is, battery stress test to do a kind of validation in the virtual environment. There are a lot of tools available in the market, specifically as a part of electromobility accelerator solution that we deliver. We can do 1D simulation for various battery parameters. So we do have ready-made electric powertrain library and the battery libraries. When I say libraries, these are nothing but the virtual test bench. So depending upon the vehicle level requirements, say for example, what kind of vehicle it is, what's its overall weight, curb weight, and what is the gradability, what would be the drive cycle for that particular vehicle, and different loads, you can arrive at a sizing of different components, which includes battery as well. Okay, so these are the first in what we call it as energy specifications for battery calculation. Okay, so once you have those parameters, you can go to one level below, wherein you can do various simulations. So for example, specifically for a NEDC cycle, number of NEDC cycle, how much is the heat generated for given battery cell. Now, one important topic here is most of the time battery chemistry and battery parameters are not made available to the startups or to the OEMs. Okay, because these battery cell parameters are studied by battery manufacturers, and they seldom share these data to the customer. So in that case, definitely we do have certain provisions wherein, based on the battery chemistry, you can arrive at certain calculations wherein you can create an equivalent RC model of your circuit, and you can basically study the charging, discharging, behavior of your battery. Also, you can study the thermal parameters, and third part is you can study the aging, which is cyclic and cylindrical. It's a topic in itself, which has got a lot of details. If required, we can have a separate session on this particular topic.
Okay, okay, that sounds good, Rupesh. Thank you so much. We have more. Actually, maximum of the questions are related to battery dynamic modeling, how to improve battery life, and so on. So I think it's worth doing a session on the battery modeling specifically, where people in the professionals in the space can get a deeper insight into how the modeling will work, what the interfaces look like, and how they can use it for their EV development. Uh, One particular question has come on the chat, and it is for Dassault Systems team. And this question is from Mr. VK Sharma. He's asking, is the simulation software available at component level, say for electronic components and for sub-assemblies like motor, from design to manufacture?
Yeah, so so the definitely simulation applications are available for component level analysis. Uh, so the example that you have used is of motor, right? So if I talk about motor, there are multiple simulations that needs to be done for motor, say, and which comes from multi-physics basically. So for example, in order to understand the behavior and overall efficiency of your electric machine, you need to do electromagnetic simulation, right? You need to understand the electric flux around your rotor and stator, and how they are interacting, and what would be the overall efficiency of the that particular electric machine. Apart from that, there would be other studies like, as I mentioned, noise and vibration. Then there would be studies related to the durability of your electric machines. So all those simulations can be done on the applications that we deliver on 3D Experience platform.
Okay. Rupesh, there is one more question, and I think this is applicable. This question can be for Mr. Mukherjee as well. It's from Nitin Shrotri, and he's asking, how much is the typical product development cycle duration for a totally new electric two-wheeler, and how can it be compressed to make it faster? Any quick thoughts on that?
You want me to take that?
Yes, sir, please go ahead.
Yeah, okay. Yeah, Nitin, as you know well, typically the traditional OEMs take anything from 1 year to 18 months for a new vehicle launch. And as we all have been talking, that the key is to shrink this timeline somehow and come for a quick model change, quick new launch kind of business model. And the only way to do is use of these simulation tools. We call it digital twin strategy, where instead of going for a hardware driven prototype or mock-up, we do it virtually. And one thing I feel is that still the virtual reality platforms have not been used as much as they should be, and they are very, very powerful technologies and tools. So using these technologies, I think it is possible to reduce it. Personally, I feel to below 1 year, I would be very happy to see, and I think it's possible. Another thing is that the simulation tools of like Dassault has, and these are modern technologies, and these are leveler technologies. These can be accessed from anywhere in the world. You can have a collaborative approach. You can have people working, different teams working on different systems with suppliers, with even marketing teams, etc. So it doesn't have to go sequentially at all, and that is how you reduce the timelines. And that is the key. Use the power of this technology to reduce your development times.
Okay. Thank you, Dev sir. So we'll take one more question from Mr. Kuntal Mandal, and his question is more generic. His question is, what are the voltage and current labels for different electric vehicles?
Yeah, it's in the industry, typically 48 volt is followed, 48 volt, or you can have 72 volts system. So that's usually the norm. So you can choose. It all depends on the system that you have to choose. Every system has its own benefits, as well as there are some issues to be handled. So it all depends on the voltage that you decide. Then your selection of your motor, your entire electrical system consisting of the the cables, connectors, etc. It all depends on the system that or the platform that you choose. Typically 48 volt is commonly used in the industry.
Yes, so 48 volts will be mostly for the light electric vehicles, right? Two-wheelers and three-wheelers.
Yeah.
And after that, for the cars and all, we of course go higher.
We go higher. That's right. Yeah.
Okay. So we'll take one last question. This is from Mr. Vijay Raj from Marelli. And his question is EPT overall design, integration of maximum parts for optimization. I am afraid I don't understand this question very well. I think Mr. Vijay was on the call. I saw him as one of the participants earlier. Oh no, I think he is left now. So I don't understand the question very well. So I think there are a couple of more questions regarding battery, and I'm afraid we've run out of time. So we will close the webinar now, and maybe we can plan another dedicated session on battery modeling next. And then all of those more technical questions can be answered in a comprehensive way. So I would like to thank all the panelists and the participants for taking the time and coming up with all of these great questions and great answers as well. So when we close the webinar, there will be a small survey to collect your feedback on how we can, what we have done well and where all we can improve, so that we can arrange more of such knowledgeful sessions in the future. Thank you so much, everyone, and have a great rest of the evening. Thank you.
Thank you very much, Priyakshi. Thanks,
Thank you.
Kiran, and thanks, Rupesh. Thanks a lot.
Yeah, thanks, sir.